Okay, here we are, the first day of summer with Princeton Hydro. They're going to do some water sampling and show you how we can do it ourselves.
Okay, the first thing we're going to do is we're going to take Secchi depth. So it's basically going to tell you your water clarity. So I mean, it's a pretty simple procedure. Here's your Secchi disc, and it's graded off the meter lengths. So you pretty much just dip it off the side of the boat, and you want to take it down just to where you can't see it. Technically, you want to take it down just where you can't see it, pull it up to where you see it again, and average those two depths. Pretty much take it down to where you just can't see it. So come up a little. So there she is. Just mark that off with your finger. Back up.
You're almost through.
So we have one. So it looks about, I'd say about 1.85, which is pretty good clarity. I mean, it's,
Is it?
yeah, it's not bad.
Good for this lake.
Yeah, generally recommends anything over a meter. You know, it's pretty good, pretty decent for recreational use. So just mark that down our book here. It's important to take notes of everything you do. So just 1.85 meters. We also have our maximum depth, which we just recorded off our depth finder. You know, you could also, if you need to, just lower the Secchi disc down, as far down as it goes. We have a handheld GPS, and we took the coordinates of the sampling location, just for consistency's sake. You know, try to keep your sampling stations generally the same area.
So when you come back, you try to do the same spot.
Yep. Try to get as close as you can. The next thing we normally do is we move on to our water quality meter. So this meter measures 4 parameters: temperature, dissolved oxygen, specific conductance, and pH. This is hooked up to a PDA that also has a depth measurement. We'll take measurements every 1 meter going down through the water column, so you get a nice profile of everything. So this actually, what's nice is this stores everything on the PDA for us. So we'll have this on internal. Basically just entered in my location. Just get this fired up really quick. This is the unit itself. You can see each individual parameter has their own probe, and there's a little circulator there to keep the water moving around, so your oxygen measurements are accurate. This is just a weighted cup that goes on it and kind of protects the probes in case you hit the sediments. First thing I like to do, this records depth, so I kind of just put this in here and check my depth to make sure it's calibrated correctly. This was calibrated this morning for each parameter, so it's important to do that so you get accurate readings. So that looks correct. So what we'll do is we'll take a surface measurement, and then we'll go down for each meter until we get to the bottom. So yeah, this is tough to see with the sun, but you can see your readings there. So you have your temperatures, specific conductivity, your DO, your pH, your depth.
Oh, I see it now.
This also does salinity, which we don't really use, and then your depth.
You say it's doing pH too?
Yes. Yeah. So just let this stabilize a little bit, and just log the location, or log all the data. Move her down a meter and just continue on.
So it sends this data to a disk or something, or?
It stores it internally on the PDA, and then we just go back to the office and download it onto our work computers. And from there we can work with the data.
How's the dissolved oxygen looking?
You're at 8.8 milligrams per liter, which is just under 100% saturation. So you're we're pretty good at 4 meter stuff. Alright, so we're on the bottom there. That's 11.8 meters. So we'll see if we can get a reading just off the sediments, say around 11.4 or so. But you're looking good. I mean, you still have 5 milligrams per liter of oxygen. That's excellent. So we'll, yeah, we can take readings throughout the summer and see how that progresses. The next thing we're going to do is just going to take the discrete samples for the water quality analysis. For this lake, we'll be doing chlorophyll A, which is it's a proxy measure for algal biomass. Chlorophyll A is a primary photosynthetic pigment in algae. We'll be doing total phosphorus and soluble reactive phosphorus, which are nutrients algae use, also nitrate, and total suspended solids, which is a measure of the particulate matter in the water column. From that data, we can kind of find out how productive the lake is, what the nutrient concentrations are. If you develop a good data set over time, you can detect changes in water quality, from measures you may be taking in the watershed or just natural changes in the lake. So we'll just grab surface samples. Just generally grab those at arm length. So we have this. It's an amber bottle. It's for chlorophyll A, so it just keeps the light out. So when we transport to the labs, there's no increases in growth. And we'll rinse this out a little bit with lake water. Just as simple as dipping it in. And we have 2 more bottles here. These come from the lab, so this is just a plain bottle. This is preserved with sulfuric acid for some of the parameters require a preservative. So just use your plain bottle to pour into your sulfuric bottle, because you want to keep that preservative in there. You don't want to lose that in the lake water.
How much sulfuric acid is in there?
I think they put like 1 or 2 mils.
Yeah.
It's pretty much just to get that pH below, I believe, 4 for the analysis. And then we'll go ahead and we'll get our deep samples. So for that we use this contraption, which is called a Van Doren sampling device. It's pretty simple.